And yeah, that's pretty much about the topic. So before I start with the topic, like just wanted to know, like everyone working in any field like navigational intelligence, like in maps or anything like that? All our college students, I know you, but not in navigation. Okay. Anyone working in Ola Maps or something that is very new in the industry? Okay. Not checking stats, but that's fine. Okay. All right. About me, I'm Deepak. I've been with part of Thoughtworks for almost 6 years now. Uh, doing here in my capacity of like a lead consultant and dev by heart. But later, I'm actually working on the AI field and stuff like that. So this is my learnings that I took during that journey, and I just wanted to share with the entire audience. So that's that. Right. So the session today, what we are planning is we will talk about like what is pathfinding, what to do, what is meant by pathfinding. We'll talk a little bit of like what are the current navigation systems that is being developed over the years, how it is working. But again, we will only talk about the breadth of it. We will not go in depth, meaning like we will not try to implement an actual Google map, but we will try to understand, okay, what does it take to build a Google map? Got the point, right? Okay, so some expectation setting here. So we will talk about different algorithms. What is we'll also try to do hands-on. We'll also have a hands-on session using Jupyter Notebook and all. We'll talk about different algorithms and also play around with something. Maybe you can also do some suggestions. We'll play around with how to make a map. So the target is like be confident enough to build a navigation system if you got a chance. That is the idea. But again, we will not talk about like real-time pathfinding, such things. Again, that is out of scope for the session. Like any production grade, not possible, not possible in 1 hour. That is the truth. Again, we'll also talk about some math concept, but again, not go deep into the math part, but we'll try to understand the overall idea. You'll get an overall holistic idea after the session. Right. With that expectation set, I think this is the agenda for the session today. We'll talk about different navigation landscape that is available. Then we'll talk about different application that is being in this domain. Like now, the next step is like what it takes to build a navigation system of your own. If you wanted to build a navigational app by your own, do you want to build on something on your own, or do you want to integrate something? There is always a dilemma, like as a developer or a business, whether we want to build something natively or like we wanted to use some existing platform, use the API cost, everything like that. So that dilemma we'll try to cover and what it takes to like identify that dilemma. So all these things we'll talk about in the by build versus die dilemma. We'll also talk about an indigenously developed navigation system like Ola. If you are following the news, that is something very recent. It's almost 6 months, but again, that is having a lot of traction. And that is also useful in this kind of like EV market, autonomous cars, all these things are actually gaining momentum. So that will help you understand what it takes to build something like that. We'll post that, we'll start with a simple POC, very small POC. We have a sample use case. We'll try to build an actual map of that system. In what it takes to build a navigation system, we'll split it into different parts, like how to represent the data for a graphical data kind of thing. What is the right data structure that we need to use? All these things we'll discuss. And then we'll discuss about the path, like search algorithms. Okay. We'll also do a comparison, and then we'll go directly into the hands-on demo part. Any questions before I move on? All clear about the agenda? Also quickly check. Okay, voice is little low.
We can hear you now.
Oh, okay. Thanks. That's good. Okay. Yeah, Prakash is using it, but not working on it. Okay. We'll try to know, Prakash, what this takes to build. All right. So when you talk about navigation landscape, we can actually like subtly categorize it into 3 parts. One is the typical landscape, which is a road network. Like if there are some road network which is connecting between 2 cities, that consists of the road. I think that is very common with everyone. But there are companies or businesses which actually not just work on this road network. We'll talk about some areas, but again, there are other areas. For example, any flights you take, international flights, it will tell you a real-time update. Okay, where are you currently? Then the top right image is actually talking about the airways navigations. Then also like any logistic company you take, like any shipping containers, they are actually having real-time updates. That is also being depicted, captured in some map when they want real-time updates of where their ship is currently. So logistic domain has a lot of use cases. I think one of the previous projects that I was looking into it is actually logistic domain. They had, that was actually a big shipping company, and they wanted a real-time data where their shipping all over the world is, where their ships are currently. So they had some information to get the GPS, and they wanted to depict that. Again, there was some interesting concept during the prototyping itself. Some of the developer was asking, okay, Google Map is free. Why can't we use Google Maps for that purpose? But again, we'll talk about like why is Google Map not free in business perspective? All these things we'll discuss. But yeah, so this is the navigation landscape. Again, roads are the major contributor. So we'll talk about roads or interconnected cities in a nutshell in this today's session. Right. So all this navigation system internally uses GPS. GPS is a coordinate system which will give you like a latitude, longitude. I think in the right side image you can see, for example, this place, Sharanapati, it has a latitude of this particular. So this latitude or longitude coordinate systems are the backbone for any navigation system. I'm talking, okay, quick funda question. If you use Google Maps and if you switch off your phone, like internet, does the Google Map work while you're on travel? No? Yes? Who are saying no? Please raise your hand. It will work? Okay, yes, it will still work. Who are saying no? Okay, if it works, you also need to answer why it works. Yeah, others who are feeling no. The chats in the meantime. Okay, right. GPS works, but how does GPS work? That is my question. If it works, then how does it work? Is GPS not using internet? That is correct. Okay, not directly, but in that. So GPS internally works on radio signals. That is the actual answer I was looking at. So the thing is how GPS works is, so there are actually satellites all over the Earth. There are actually 31 active satellites when last I checked. So these are actually contributed from NASA, US government, everything. So what these satellites do is they continuously emit radio signals to the Earth. So this signal transmission, radio frequency signals I'm talking about, this radio frequency signals gets captured by your mobile handset. Any mobile handset, latest mobile handset will have a GPS receiver. It is working on a radio frequency. That's why we don't need internet. So next time you try to go, and if you're having low on bandwidth, you can switch off the internet and the Google Maps will still work. But again, there are challenges on doing that. You will not get real-time update if there is going to be a block. So, but still it works. So, and how it is actually working on the receiver part is like these mobile handset, which is having GPS receivers. I think latest version of PCs and all are still working using GPS satellites, sorry, GPS receivers. And then the triangulation or identification of the real-time coordinates, it's happening something on the locally, on the device itself. So what it does is, so if this is your device, there are four satellites which are at least four satellites if it's continuously in it. It's able to triangulate what is the frequency with respect to these four satellites, and then it is able to identify the latitude and longitude. Okay, that is how the real-time updates or the GPS coordinates real-time tracking actually happens. We had an interesting use case in PCs. What if we wanted to build a geofencing system? What if my laptop, I don't want it to go beyond this area, just for safety concerns? So again, all these things work on GPS. This is also one important area if you wanted to understand the POCs or what it takes to build a navigation system of your own. That's right. All right. Now, moving on. Yeah. Right. So it is actually relative concept of relation. So one, you get a signal from one satellite. Okay, how much distance we are taking? We are actually having some data. The radio signal has some data where it is positioned currently. So with respect to that, four different satellites are constantly communicating. At least four satellites, you get the radio frequency signal. You are able to triangulate up to 6 digits. I don't hear the question. Sorry, I'll just be watch out for that. You get the question and get the answer. Right. No, position of satellite is also changing, but whenever whenever this, okay, that question was for you. Whenever a radio frequency comes, like signal is being broadcast, right? During that time, you get you will get a relative. Okay, where is the current satellite positioned? That satellite knows where it is positioned related to Earth. So it will also transmit some information from that side. Similarly, there are other 3 satellites also positioning where they're currently positioned. So based on that information received, this mobile handsets try to decode. Okay, with respect to this signal I received, this satellite is here, maybe say 10 degrees. I'm just taking an example, 10 degrees towards my east side. The other one is, so based on these 4 satellite signals transmitted, it tries to identify. That is a triangulation. I'm not going to the depth because that is more trigonometry. You will need to understand more math. But again, it's not a new tech. It's been there for a long time. It's almost all your devices, mobile devices, later mobile devices, everything has GPS tracker within that. All right. The top apps, I think nowadays, I think the e-commerce sites, everyone is actually booming. If you think of like you have a 10-minute delivery, you order something, you get a 10-minute delivery. All these are actually possible because of this real-time tracking, GPS, and also there is a like internet is being freely accessible, not freely, almost like accessible for everyone. So that is one of the reasons these kind of new logos that you see, Blinkit, Zepto, Zomato Gold, Swiggy, all these things are actually like a lot of startups in that area. I think Zepto is going to go public or IPO in another 1 month or something. So all these interesting like applications are actually built on this one. On the left side, you can also see there are some, historically also there are a lot of things. Anything you have used in this segment, in the left bottom segment. Anyone you have used? Zomato you have used, yes, obviously. Zomato, Swiggy, this is something very common. Uber Eats got acquired, but yeah. Yeah, I think there are around the world, there are a lot of companies, like there are a lot of business which are delivering food. For example, DoorDash, Grubhub, and all is very popular in US. I think Deliveroo is very popular in Australia. So a lot of companies are actually surrounding, like built using this kind of navigation systems. Okay, forget food delivery. What about ride hailing? That is Ola, Uber, Rapido. I think Rapido nowadays has actually surpassed the majority of the like what I meant is like the volume of traffic that is Rapido got is they're actually beating Uber and Ola. So Rapido is actually expanding in a crazy rate and it's actually also surpassed the volume of the request or the ride hailing system by Rapido. So that is something recent news. Right, under the hood, if you see in the right side, right, all of these are actually using Google Maps. You can see here, there's a Google symbol somewhere. If you're using Google Maps, you might have seen, if you're not observed it, like next time you book a ride, check this. This is actually very interesting part. Right. Now, if you wanted to build you are going to start a new startup, building around navigation systems, like what's your like go-to-market strategy? Whether you wanted to build something on your own or do you wanted to buy? That is the first question, eternal question that any business will have, right? If you wanted to build your own, what it takes. Again, I'll talk about that later. But if you wanted to purchase something off the shelf, so what are the existing platforms? For example, Google Map is a very interesting platform. Most of the apps nowadays are using Google Maps. Is there an alternative to Google Maps? So such things, yeah.
OpenStreetMap.
Okay. OpenStreetView, yeah, that is correct. OpenStreetMap is another concept which is actually general. But again, there are not traffic updates, something like that on that one. Yes, that is a good candidate to try. Anyone has any other ideas apart from Google Maps, OpenStreetMaps? Here, I am not sure on that. Okay, I think Preem was saying that Ola has come up with their own Ola Maps. Yeah, that is one interesting topic. If you're not aware, Ola has actually indigenously developed something on their own called Ola Maps. So
Ola Maps is actually based on OpenStreetMap.
right. Yeah, right. I'm not sure who spoke, but yeah, that's correct. OpenStreetMap. Right. So let's talk about like how to like integrate with some existing thing, because that is actually faster. You don't need to build everything on your own. You can start integrating. So typical standard that we have is the first buy option that you want to integrate is Google Maps, obviously. That is a clear indicator. in almost 99% of the current e-commerce site, like e-commerce or any delivery sites uses Google Maps in the backend. They are integrating with their API. One quick question, is Google Maps free? Paid any time for using Google Maps? Right. So that is the answer for that. So Google Maps is actually free for like public. It is Google Maps are actually automatically integrated in your Android OS phone. It's also there to some extent in your Android iOS phones also. Not just Android, iOS phones also has Google Maps. But anyone use Google Maps like Apple Maps and all from iOS side? Participants. Okay, that's kind. So, right, Google Maps is obviously the clear choice once it's built. But again, if you have tried integrating a Google Maps solution to your API, it was actually very costly. You request an API, the API cost was actually, say, very, very high because it was actually clearly having a monopoly over the market. That was a clear choice. But again, that comes with its own risk. You don't have you don't have an alternative choice. Whatever they dictate the charges, you'll have to pay for the API. Again, think of an example of like a Rapido system. You are using a ride hailing Rapido and you are actually taking say 100 rupees from the customer for that ride. 20% you are taking, like 20 rupees you are taking for platform fee. But out of this 20 fee, like you need to go for the API charges. That might take around 10 to 15. I'm just taking a rough example. Then what are you left with? What's your business operandi? Like modus operandi is actually failing here, right? So not all the time like this kind of model scales, right? That's why Ola came up with new one, right? Yeah, I'm coming to that one. So I think last August or something, till August, so the pricing plan of Google was you use the API, you are getting charged, and that was charged even in dollars. For example, I'm just giving a rough estimate, $1 for one API request. So the moment the Indian customers, the dollar ratio or dollar to INR ratio goes up from 60 to 80, you'll have to pay higher. So all these problems are actually making why Google Maps integrations are very difficult for businesses. But one interesting thing happened is like from last August, Google has changed their entire pricing model itself. They changed the like payment now accepts in INR. That is one interesting point. And also they give a crazy discounts, like 90% of discounts for ONDC, 70% of discount for startups. Any guesses why that happened? This happened last 6 months back, but exactly. Yeah, actually the credit goes to this Ola Maps. So Ola actually, the CEO Bhavish Agarwal has actually acquired a company called CrewTrim. It has actually developed its own AI navigation system, and they have actually branded it, ingeniously developed, and they are actually branded it, and also they are giving it for enterprise use case. For example, you use the API, you can see here, right? The first year actually completely free. This actually interested a lot of startups, a lot of companies which are dealing with navigational, and they actually started migrating from Google to Ola Maps. This was actually a revolution which to break the monopoly of Google. In full credit goes to actually Bhavish for that purpose. But this is one area. But I'm still thinking like Google is still the better option. Why? Any idea? Ola is having like crazy discounts, like first year free, all the usages. Right? But what about real time? That is correct. So one thing is like if you're not a community person, so yeah, one is someone is telling real time data, maturity, all those are valid points. But apart from that, that is the community initiative. So Google gives something for free. And if you are interested in like sharing something, I think Santosh here, he's actually one of the crazy contributors, almost 5,000 contributions in last 5 years. Whenever he goes to some place, okay, it is not there in Google Map, he tries to take some pictures, like give some additional data. Obviously, those details get reviewed by Google and it's placed. So that community initiative is something which is actually making Google still strong. Like over 9 years, still being the stronger option when it comes to the navigational system. Again, this is one area that I wanted to share. If you also wanted to help your fellow, like any other persons, you feel, okay, you go to a new shop, it is just booming, but it is not updated in the Google Maps. You can also update. This is something that you can try. I just wanted to bring it here so that I had to have like what it takes to giving back to community. That thought process I just wanted to start. Right. So we talked about two options. I think Ola is a clearly better option in case of money, but if you think of like maturity and all, Google Maps is still the best option. And Ola Maps is actually built on OpenStreetMap, as you rightly said. Someone also highlighted. prompts. I'm just checking the chat. I should get paid for this. Yeah, I'm not sure. Did you? No, it is not a paid thing or something. It is something like, okay, you wanted to help your people. Like we are a community of like several people. So if you feel like this information will help, do that. That is something that you can give back to community. You don't need to get charged or paid for that. Okay, let me move on to the next slide. So now we talked about different buying options. You can buy something, integrate something much faster. Let's also talk about what it takes to build something of your own. So in this problem statement, what I have is a map of some cities. Okay, almost the southern cities of India has been captured. Again, if I miss some cities, don't worry. It is just a prototype. Right. So we have cities from Panaji all the way from Goa, then to Chennai, then almost all cities, major cities at least, I try to capture in this map. So how to read this map is like, okay, from Panaji, there are two roads, two national highways, you can assume. One is to Bangalore, which is 365 kilometers away. Similarly, the other one is for Raichur, which is 457 kilometers away. For example, let's take this example, Bangalore. Bangalore has multiple connections. So if you come to Bangalore, we have different routes to take to Bangalore, Kozhikode, Bellary, Chennai. Multiple choice. So this is a typical representation of a map. Again, if you wanted to build, say, like, for example, I'm not sure, Rapido came here some time back. If they wanted to come and establish their business on some location, they'll do this groundwork. What is the exact map of this? And that's typically example of like how to build your own map system. So this is a simple example. And in the right side, you can see all the cities and what is the latitude and longitude. We'll find that useful in one of the areas while implementation, but this is just the information, the GPS coordinates of those cities. Okay. Now, the quick question, like if you wanted to convert this into a like application of your own application, what is the first thing that you'll do? Now you did the groundwork. You have all the data now. This is the data system. This is the data of the map. You have did the groundwork and collected this map coordinate system, and also the latitude, longitude, everything. You wanted to build your own navigation system now. Meaning, if I search for a place, say Raichur, and if I wanted to go to say Chennai, what is the expectation is it should propose. Okay, this is one example. Raichur, you take a Tirupati road, and from Tirupati you take a Chennai road. That is the end goal. Everyone with me so far? Okay, what is the first thing that if you wanted to build something of your own, what is the first part that we will think of? Again, forget the AI part. This is a simple software text part. Yeah. Can give the mic because there are people in. Okay, converting it to some data structure to use.
Coordinates as the places as the nodes. Not sure of that approach, but like something of that sort.
Okay, I'm not sure whether Zoom audience got it. The answer was we first need to convert into some data structure such that our program or our application can understand this. This is a graphical representation, like this is a pictorial representation. How to convert this into some data structure? Exactly. The first thing that we'll think about is like data representation part. How do you implement this map data, that the groundwork you did, how to convert it into a suitable format such that our program, we can actually build on top of that. We just need to convert, use a suitable data structure or something of that sort. Again, quick question. Anything that comes to your mind, which data structure would you use? So, this is a very simple use case. Graph, okay. Prakash is saying graph. Anyone else? This is a simple use case. You don't need to complicate stuff. How will you represent this data? Like you will create into a tabular structure, put it into the DB, or like you can be wrong also. You can please speak up.
Can I go like so from
What is the
Panaji, there are,
connections?
so basically the connections we need to map.
Right.
One point to one another.
Yeah, right. I think that is correct. Satish is almost correct. Just for Zoom audience, I'll repeat. We just need to map it to some structure or some classes such that it actually captures the essence. For example, from Manaji, there are two connections, Bangalore and Mangalore and Raichur, and this is the distance between it. That is the first target, right? Actually, that's what we did. That's what we did here. Again, nodes and edges, all are valid points. Again, for this simple use case, let's take a very simple use case, simple class structure. We can actually convert it into a like graph, AVL, all these things is possible. But let me explain with this example. So what we did is, I just created a class called connected city. It will have a name and distance. Simple, one class, please. All clear? Next part is, I created another city, which will have a name, and it will have an array of connected cities. Clear what it's meant by connected city? So basically what I am representing here is, I have an array of cities. Within that, I am setting a city called Panaji, which has an array of connected cities. So the first connected city is Mangalore, which is 365 kilometers away. And the second city is Raichur, which is 457 kilometers. Again, this actually changes. For example, Raichur has 3 connected cities. So since it's an array, it can have multiple data. It will have Panaji, it will have Tirupati, and also Kurnool. Again, here I'm capturing also the distance between those. Simple enough? Okay. Let's move on. So once you implement the data representation, you represent the data. What next? What next? Using an algorithm, right? That is the crux of how we need to implement. So if I choose a Panaji and I wanted to go to Chennai, how can I convert? How can I create a program or algorithm which actually finds a connected city using this information and help me reach the target, right? So I think the second part is actually the algorithm part. So there are different kinds of pathfinding algorithms in the market. I think some of the like popular ones are, okay, if I wanted to classify it into two, there is informed search and also uninformed search. I'll talk about uninformed search first. Uninformed search is like blind search, meaning like you have some data and it will try to like go on some pattern. I'll talk about some patterns in the next slide. It will try to give, like try to force fit and then try to come to a destination. Okay. And the classical example of uninformed search is like breadth first search, depth first search. We'll talk about both. And also there is another class called Digitra. Again, Digitra is actually was implemented for networks. If you wanted to a network system, if you wanted to pass some packet data through some network and all, it will be able to try to find the optimal path. It is using weighted graphs, but I will not talk about Digitra. But again, that is advanced version of Digitra is called A-star. Okay, so when it comes to informed searches always uses some heuristic. Okay, I'll talk about heuristic, what is heuristic and all. So using this heuristic, they will try to find a pattern and then come to a traversal path. Clear with so far? Okay, in some ground rules, pathfinding means we need to find some path from this point A to point B. So shortest path or optimal path means like you need to find the optimal path. Again, if you are trying to create a navigational system, always set this expectation to the business. I'll try to find a path, but it may not be optimal on the first run. If you are thinking of like, I will always try to find the optimal path, there are real-time updates, all things playing, you know. So this is something that you always need to set the expectation with business. All right, so let's talk about BFS and DFS. These are uninformed searches. So breadth first search, what it does is, okay, if you wanted to go from 0 to 6, so breadth first search, what it will check is, okay, from 0, what all are the connected cities? If there is a connected city 1, it will try to go to connected city 1 and then see, okay, is 1 the target? The target I wanted to go is 6. Okay, is 1 the target 6? If not, it will try to go in the same layer. What is the next connected city for this node? Clear? So this is actually expanding every node and then trying to figure out, okay, am I reaching the target or not? And then if yes, it will try to map, okay, you need to go take this path. Clear of BFS, breadth first search, right? So depth first search is actually another version. It actually tries to expand all the nodes like synchronously. So from 0, I have a connected city, say 1. It will check, okay, it will go to 1 and it will check, okay, is 1 the target that I need to reach? No. Then it will again try to expand 1. The next one, next connected city from 1 might be 3. So it will come to 3. And then see the 3 does not have a non-visited node. Then it will try again go back 1 layer up and then try to go to next connected city. So it is actually going in the depth first approach. Clear about this too? We will have a, yeah. Right. So it expands layer by layer in breadth first. So 0 has 2 nodes, say 1 and 2. So it will try to expand, okay, first one. Is 1 the target? No. Then it will try to expand this next node. That is 2. Then it checks, okay, 2 is the next target. Do I have another node? No. Then it go back to the first node and again checks what is the next thing. So it is 0, 1, 2, 3, 4, 5, 6. That is breadth first. Okay. Depth first is actually, it tries to go from 0, it tries to go to 1. Is 1 my target? No. 1, does it have any another expanded node? Does it have any connection city? It will try to expand 3. So from 0, 1, and 3, it will go. 3 does not have any expanded node. Then it will go back to 1 layer up. 1, does it have any other unvisited node? It will try to see 4. Yes. 4 also does not have. It will try go layer. So the approach is actually different. But clear on the implementation, what is DFS, BFS? Okay. Some chats, let me quickly check. Okay. There was one question. Which algorithm is very popular in Google Maps? Anyone has any idea? Like I talked about algorithm. Obviously, A star is the clear deal breaker. I think they are using A star a lot. We'll talk about A star only for this today's implementation. But yeah, but just to have that breadth of what are the different algorithms, that's why I put it. So BFS and DFS, these are blind search kind of searching algorithms. Okay. Now let's talk about informed searches. Informed searches, as I told before, it is using a heuristic component. Heuristic component is something like, okay, I am a local guide here, say like Santosh. So Santosh knows this area inside out. So he's telling, okay, if I wanted to go to a railway station from here, either I can go to the right towards the Sharonapati side, or I can go take the left, go from the Reliance Mart left, that road. But he's a local knowledge. He's a local guide, and he tells, okay, Sharonapati signal will be always crowded, so try to avoid that and then come to this spot. So that is some local knowledge, right? So any kind of local knowledge, if you can convert it to some number, that becomes a heuristic. It does not have a unit or weight, but some number which will help me identify, okay, I need to take this path instead of this path. That is called as heuristics. We'll try to create a heuristic in our use case, but understood what is heuristics? Okay. So all these informed searches like A star, GBFS, greedy best first search, all these uses heuristics a lot. And these are informed searches. So this is a classical example of a map with heuristics. So the one in orange is actually heuristics. For example, if I wanted to go from A to Z, so it is actually having some information. So this is, so this can be thought of some number. So if you wanted to go from A to Z, he's telling, okay, from A, it will take say 30 minutes. 30 minutes or like 1 hour. So that number is getting represented as 21 here. So if I take a route, say to C, from C to Z, it will take another 18 minutes. I'm just taking a rough number. So the details here in orange are heuristics. What is the numbers that is like 947? Right, that is the actual distance. Right. If I know, okay, from this position to this position, I need to go, if this is the actual distance, but again, from here to there, for example, from B, I need to go to Z. To Z, it might take another 40 minutes. So that is some local knowledge that is represented on the orange. All clear so far? Okay. Right. Again, just quick comparison, and then we'll go to directly to the demo. So if you thought about like BFS, DFS, Digitra, these are actually blind search algorithms. When you choose an algorithm, we need to also think about like optimality, completedness, and stuff like that. So what is optimality is, BFS and all is an optimal kind of algorithm, meaning it will try to find a very optimal path. Again, it not be 100% correct, but it almost 90% correct. Okay. DFS and all need not be optimal also. It can also find a very worst case scenario. Any reason why? I explained the theory part. How is DFS done? How is BFS done? It's optimal. Like, I'll go back to the screen. DFS is not optimal, I'm saying, but why it is not optimal? Looking at the graph, anyone has any idea? Right. See,
yeah, it actually goes to each and every node to check whether it is unoccupied or visitor or not. So the route might be wrong, even though.
Right.
So
That
there
is
are
true.
possible of high chances probability.
Exactly. So that is actually a very brute force kind of way. Like we are actually going in depth and then trying to figure out, okay, it is not that route. I am taking a step back. So that is actually not a very optimal solution. It can give you some data, it will give you some answer. Okay, you need to take this route, but that never is optimal 99% of the time. That's why, oh, that's why it is considered not optimal. Again, there are other fields of optimal algorithms like greedy best first search and all. We'll talk about what is greedy best first with hands-on, but that is also not very optimal all the time. A star is actually very popular. I think it actually checks all the boxes of what is an algorithm that we need to choose. I mean, that is a version of A star, like A star epsilon. There are different versions, subversions of A star. Actually, that is the one which is actually in play in Ola Maps or Google Maps. If you take under the hood, it will be using A star algorithm. Okay. Completeness means like, okay, if there is a possibility, I wanted to go from A to B, A to say Z. If there is a possibility to go, it will try to find. That is meant by completeness. That algorithm is complete in all the sense. In DFS, since it is going in multiple depth, if the depth is actually too huge, for example, say I have a 1000 node depth, it will never be complete, right? So that's why it is not complete DFS and all. Again, that depends on your data. For this use case, it will work, but I'm just saying. Right. So far, like we have told about the different theory part. Let's go into the hands-on part. Okay. Okay. I talk about heuristic, some local knowledge. Let me go back to the problem statement. Okay. This is the groundwork which your data engineering team or your some team identified and then created this map and the coordinates of these systems. Is this enough for informed search? Like, can we create some heuristics out of this data? Obviously, we have direct connection data, but heuristic requires, okay, if I choose something like Chennai, is it possible to get some heuristic of Raichur? You get my question? Need more data points. Is this not enough?
Traffic, like you said, could be.
Okay. Yeah, so traffic is other than external. We are not going for traffic, but with this information, can we create some heuristics? Is it possible? Some local knowledge such that, okay, I wanted to go from Panaji to Chennai. Without a person like Santosh, is it possible I need to take a Raichur city or Bangalore city? Can that decision be made with this kind of data? Is it possible? That we already have, right? From Panaji to Bangalore, we have a national highway, which is spanning 365 kilometers. From Panaji to Raichur, we have 457 kilometers. I need to go from Panaji to Chennai. I'm just taking an example. Which road I should take from Panaji? The Bangalore route or Raichur route? I don't have the data. Like I have the data, what is a kilometer? But which one should you use? Algorithm needs to have some number rate.
For referring to the time or time for the distance taken, the
No.
heuristics,
Okay.
or we are meaning about the distance only, the heuristic value.
Actually, not the time. We don't have time parameter at this moment. So what we have in the right side is latitude GPS information we have. So can this GPS information be used for computing heuristics? Any thoughts on that? Like I'll take a pause. Any thoughts? Like, is that useful for constructing a heuristic part?
Altitude you can find.
Altitude, huh? Latitude, longitude. Huh? Okay.
In
Actually,
my
that
mind, I think we can try. For example, with the help of the latitude and longitude, we can try to build a line. A line means connectors, so that we can try to visualize that. So with the help of that, we can able to find some outputs or response based on that. So just
yeah, I think Balaji is spot on. I think that's the answer that I was looking for. Yeah, that information can be used to visualize. Okay, this latitude, longitude, with that information, if I am taking a route to Bangalore, is it taking farther away from me to Chennai? Think of it like a line of sight. Am I taking farther away? I wanted to go to railway station. There is no point in me going to the opposite direction, right? See, I don't know whether this is opposite direction or it is taking me closer. You get my point? Okay. So that is something that we'll do. So we'll try to come up with a heuristic computation first, such that we understand, okay, taking any route, is it taking me closer to that target, closer to the destination? Okay. Okay. So that's what we are going to do first. So the first thing is how to use this GPS information and then do the computational part. Okay, so if you're not sure, have you ever anyone worked on like, okay, what is, if I have a circle, what is the perimeter of the circle? I have a circle of radius r. What is the perimeter of the circle? The circumference, 2 pi r, right? So if I have 2 points on a circle, say A and B, what is the distance between 2 points? There is a calculation involved. So we need to get an arc created from the center. What is the angle of that? So similarly in 3D, like Earth is a 3D, like it's a globe, right? It's a complete sphere. So if you wanted to get distance between 2 points, okay. So let me show you this example. So I have the Earth position here. I have 2 points, say A and B. If I wanted to get a straight line distance between them, not a straight line, but Earth itself is a spherical, like it's curved, right? So I wanted to get a curved like distance from one point to another point. There is a formula called Haversine. So this Haversine formula can be used to identify the great distance, basically, great circle distance. Just highlighting between 2 points. Okay. Now, we only have latitude, longitude. That is a GPS coordinate system. So using this GPS coordinate system, how can we convert into a great circle distance? Okay, you understood what is great circle distance? This is like a crow is flying. So this is another, like, as the crow flies, what is the distance between 2 points? So if a crow is flying from, say, 1 point to B, it does not go to the roads, curves, everything. It goes in a straight line or around the Earth, right? So that is a crow's fly distance, or it's also called great circle distance. So there is a formula involved on that. Again, I'm not going to this trigonometry. You'll need to understand a little bit more trigonometry, but there is a formula which allows us to calculate if you have a latitude and longitude information, and we know the Earth radius of the Earth is something like 6,371 kilometers. That is already given. It's not going to change anywhere if you go inside it. So using this information and this formula, we are going to calculate the distance between each points. Clear what you're trying to do? I'll go back to the lab. So this is the formula, and that's what exactly what I'm doing here. Okay. So I have this information. Panaji has this latitude, longitude, Raichur. Every city has this GPS information. So what I did is, from Panaji, I wanted to go to Chennai. I'm just taking a classical example. So from Panaji, there are only two options. I can take either Raichur route if I go back to the prelim statement, or there is someone, I think Kurnool. These two cities. So which city takes me closer to my target? For that, I'm going to calculate the heuristic function. Heuristic function, what it does is, it actually tries to use the Haversine formula and tries to map the distance. For example, if I give Chennai to Chennai, it will give 0. Why? You're already in that. There is no distance. Right. From Panaji, it is almost 744 kilometers. This is a great circle distance to Chennai. From Raichur, it is taking 468. From Mangalore, it is taking 586. So this is some additional information on top of the kilometer readings that we have between the cities. So this will actually help me guide, okay, if I take the Raichur route, it is actually 468 kilometers closer to Chennai. Again, it's not the actual distance between Chennai, but the great circle distance between Chennai. Clear? Okay, so what I did is I created this kind of graph, and instead of, again, this is one example if I wanted to go from Panaji to Chennai, but if I wanted to create a heuristic function, a 2D graph basically, across all cities, then I just put it in a loop and then created this one. So what it is doing is, it is creating every city with mapping every city with other city. This is the heuristic computation. So what it is doing, from Panaji to Panaji, it is 0 kilometers because we are still in the same city. There is no distance. But from Panaji to Raichur, it is 384. Panaji to Mangalore, it is 307. So this distance is getting mapped. This is a great circle distance, heuristic information. Clear with me, Solver? Then the next part. So you have now the heuristic information as well as you have the actual distance. Let's go to the A-star algorithm. Okay. Before I go to the code, I'll just explain what is A-star algorithm with this graph itself so that you understand the code much better.
Yeah, I hope you can hear me. So I have a question here. Can you go back to the like the problem statement, the one with might be quite stupid, but like I just wanted to understand if this one, right? So you have the latitude and the longitude. So in this case, can't you calculate the angle between, like, say, Tirupati and Nellore? You have a, we'll say it's road,
Let's say 30 degrees.
30 degrees.
South or
If you're on the opposite direction, it is going to be negative, right? Like it is going to be, then can we take, why go on, like go into all
Calculate.
this pain? Can't we take the angle and start calculating?
Right. So as I said, heuristics is not a like exact kilometer. It does not have a unit. You can also calculate time. Okay,
Right.
what it takes to take from here to here, like historical data or the real-time traffic updates if you have.
Got it. But
For
like,
this example I tried, have seen, there is no hard and fast rule. You can also use angles.
got
But
it.
angles as a unit, but then you need to convert that angle, for example, 30 degree or 180 degree. Actually, not just that information, whether I am going in the opposite direction. I also need to know whether I am getting closer by how much. It should be measurable.
Got it. But like that would be dependent on the distance, right? I'm not traveling in a straight line. So Tirupati to Nellore, probably I'll have to come to Chennai or like, I mean, come to Chennai and Nellore,
Right.
right?
So there is no connection directly from Tirupati to Nellore. You're right.
But in the but with an angle, I can say I can rule out Bellary and Raichur because I'm going in the opposite direction. To an extent, I know this is wrong. I'm just
okay.
supposing
so the
this is
map
this
graph is this is also rough graph. It
Right,
is
right,
not
yeah.
exact graph, but I hear your concern. That is also possibility.
Right.
Angle can be also used as heuristics.
I have an example. I don't know if the angle will be like I just thinking. Imagine there is a, like there is a hill between like Western Ghats between Kerala and Tamil Nadu, and let's say you have to take a long winding road which eventually comes back almost like a U as an example, right?
Right.
And same is true with Karnataka and Tamil Nadu as well. In those kind of examples, I don't know if angle would still work, but that's where I think there's different considerations. We have to validate for those different scenarios, right? What does it mean?
Actually, you are trying the same problem statement which Google tried several years back. When they tried to establish like a Google map in India, they were actually dealing with all these problems. First one is there is no connection. And unlike US, which was a success, Google Maps, when it comes to India, all our roads are curved roads. As you rightly said, there might be a map which does not have a connection. And even our roads, 99% of the time it is a curved roads. So they are not able to correctly map that graphically, visually, show it. Again, they all tried all these possibilities. Angle was one thing that I know they might have tried. I don't know whether I did not work on that, but that is also they might have tried. Anything measurable is possible for heuristics.
So my question boils down to like, why did you decide to like go with the great
Okay,
circle?
so I have that is easy computation. I can go with that. There is no hard and fast rule. Just for example, I tried heuristics. I like Haversine distance, which is actually very easy to calculate. If I know the coordinates, I can calculate it. I can also go with like degrees, but again, then I need to
probably something else. My question was like, is there another approach that I can try, or like this is a proven one?
Actually, Google tries more. They try this Haversine. They actually does a combination of all this. They try the angle, they try the Haversine, they try the real-time updates also. What is the current real-time updates? What is the traffic in these roads? All these concern like combined and then populate the heuristics.
Right. Thank you.
Just one of the parameter to measure.
Sorry, what was the question?
So this is one of the parameter to measure the distance. So we have multiple parameters. So at the combination of everything, so we are going to select the shorter distance or the optimal way. So as a result, that's how real-time maps works. Is it right that we are trying to conclude? Oh.
So yeah, that is correct. So actually, lot more are there. There might be say one-way connection between these cities. There is no two-way. There can be also problems like there is some road work and the road is closed. All these problems come up in real time. So see, real-time updates of traffic happening. Okay, if there is a crash and it is blocked, so it will route you, right? So all these things are coming. So that actually Google did not develop this in overnight or something. It is actually 9 years of like incrementally updation, like fine-tuning all this. So yes, what I meant to say is like there is a combination of everything. This is one such parameter, Haversine distance.
You told about great circle distance. Do you think it's relevant to short distance? For a large distance, Earth is where it is made relevant. Do you think for short distance, it is relevant or not? For shorter distance.
Google Maps also does this. See, I gave it like 4 different cities just for pictorial representation. Google Map actually has this on a multiple smaller level. They have each connected roads between that. They does it in a like very huge data set. They have interconnected roads. There are, for example, I just go from here. I have a right or left. So all these roads are getting mapped. So that is actually the data population will constitute then 70% or 90% of your product. But if you are thinking of like smaller area, for example, Coimbatore, I just wanted to create a new application like Rapido, and I just wanted to start business in Coimbatore. Say like I'm starting a bakery and I wanted to do food delivery from that bakery. So you know like what are the adjacent routes. You can create small maps. For example, like this, small roads. Okay, you take from say my city, one city A, not city, like you're from your bakery or some shop, and what is the next connected road. You can actually do it in like 100-meter also. This is in kilometers. You can also do it in meter range. There is no problem. It is possible.
So with that range, there is no need for great circle distance.
Right. Still we need. So there are 3 roads from your shop. Which route I will take? Should I take the right or left or the back? I'm just taking one example. How will you decide? You know the customer lives in say some other coordinates. Say they have booked from their app. You know the GPS coordinate of the system. Which road I will take? That information needs to be there, right? Without that great circle distance, I don't know whether I'm going that route or I know there are different cities, different roads. For example, the road 1 takes say 1 kilometer towards right. Road left takes 2 kilometers to the. There is also one back, say front. I don't know which route to take. How will I decide? Some heuristics needs to be there. So great circle is actually a very good measure to do it. You get my question?
Yeah, I got it.
Like without the heuristics, how will you decide?
Not about, yeah, we need heuristic. What the great circle distance?
Okay, why great circle distance is heuristic? Okay, that is a question. Okay, that is optional. If you know, okay, the angle concept which Ramesh was telling, the angle works for you. That can be considered as a measurable heuristic in your case. That is not a problem. Again, you can also do more. Okay, you get a real-time update. Someone has already gone and told you, okay, don't take that route. There is some traffic. For example, I gave an example, right? Sharonabati station will be always crowded this time. So don't take that route. That is some local knowledge. You can convert that to some heuristic number. That helps you to decide, I should not take this route. I should take the other route. Anything can be heuristics. There is no hard and fast rule. Haversin is the only heuristics. Check the chat as well. Okay, I think, yeah, this will be the ultimate test bed for self-driving cars for sure. Okay, so we were talking about A-star algorithm. We got sidetracked. So A-star algorithm, what it does is, we have the actual distance. I'll use them. So I have the actual distance, say 9. So from A to B, I have 9. From A to C, I have 4 units. From A to D, I have 7 units. I also have the heuristic. From B, it takes some 14 units to go to my target, say Z. Okay, so what this A-star algorithm does is, it will sum up the 9 actual distance plus the heuristic distance. So 9 plus 14, 23. So that is, if I take the route from A to B, it will take me 23 units. I'm just taking a measurable unit. Okay, similarly, if I take the route A to C, it will take 4 plus 18, that is 22. So 23 is bigger than 22. So that gives you some comparison. Okay, if I take the C route, that is giving some additional information. It will take me closer with this much unit. So what this A-star algorithm does is, it actually tries to sum up the actual distance and the heuristic value, and then it tries to compute, okay, which route I should take. So in this example, 9 plus 14, it is 23, 18 plus 4, 22, then 18 plus 7, 25. So out of that, so it actually tries to reason. So which route is actually, which node gives me the lesser value? So obviously 4 plus 18, 22 is lesser among the all 3. So we'll try to go from A to C. Clear? Okay. So that is A-star algorithm. It actually uses the actual distance plus heuristics. Greedy best first search is, it does not use the actual distance. It only relies on this heuristic distance. So it is trying, okay, from A, it will try what is the heuristics for all the connected cities. So for example, B has 14, C has 18, D has 18. So which one is smaller? It will take that route. For example, if you try implementing a solution with GBFS, greedy best first search, it will try to traverse a path from A to B. Clear? What is A-star and B? There's no BFS. BFS, DFS and all is, no, BFS and DFS is actually ordered one. So it does not reason which route I need to take.
No, in BFS or DFS, it will have in the end the sum of distances between the points, and then it will sort and find out which is the shortest one.
Right. But here
Because
BFS is without
like
search.
4 or 5 may be connected, maybe 6 and 7 may also be connected in different way.
Right. See, I didn't fully understand your question. Speaking.
Yeah, I have a little bit answer for that. So for the BFS and DFS, that the parent node or the actual node that has to visit that particular node. For example, it has to traverse for each node to find out the best way, or each need to calculate. So before switching to one node to another node, so it will take some much more time, or it might not be optimal. But in the A plus, so before switching to another node, there is some decision making is happening. So this is what I have just understood.
Okay,
Santosh,
my
correct me.
question on this one, like if you can go back to the A7, sorry, I'm sidetracking your
Yeah.
conversation, but like see, A to D, A to B, and A to C are three options you have. So you're actually traversing these three from at this point, and then you're making the decision, right?
No, we are not traversing. It
I
is
mean-
actually deciding which one to take. Yeah. But I need to know this heuristics plus actual distance. That I computationally am doing and then going. Okay. It
Okay,
is suggesting. I didn't go to that node, but it is suggesting, okay, you need to take the B route if you are using GBFS. If you're using A star, it will tell you, okay, you need to take the C route. From C, it will try to expand whether I need to go to E or F. Again, that is based on this logic.
Got it.
Clear? Okay.
So it will not calculate until the destination. So it will see whichever connected first. It will see which route to take based on the heuristic and the actual value.
Right.
And then again go to that node and then calculate which is the right.
What is the next connected city?
Connected
Okay,
city.
one thing I forgot to tell you. If you have already come to C, if you have already visited A, it will not try to check the already visited nodes. Otherwise, it will go in circles. I go from A, from C to C, and again from C to A. Why? That becomes a problem, right? It becomes an infinite loop. So if you already visited some node, it will never try. It will try to skip that nodes. That is always a ground rule. I did not tell it before, but that is something that I always need to do. Otherwise, you will always question this. I'm going from A to B, going to E, then coming to C, and again coming to A. It will go in an infinite loop. So, right, because A is already visited. So any already visited nodes, it will skip during. If you can speak.
Heuristics and that actual distance, which is more than other nodes, right?
Right. I'm just saying blind first. Okay, this is based on heuristics, but if you're trying DFS, BFS also, same concept applies. Heuristics is actually, if this heuristic is wrong, it can actually take me back in circles. That is something.
Okay.
I am using Haversine formula. Haversine is actually very dominant formula. We know that is great circle. There is nothing going to go wrong. But if you try, for example, like some knowledge, I am using a guide and telling, okay, this can be say something 24. This can be say something like 5. If you try to calculate, you will not get into a because heuristics needs to be like sustainable kind of heuristics. There is actually a mathematical also to calculate the heuristic, but Haversine formula is actually very simple formula. It will not go wrong based on heuristics. But if you try to put other measures, it can actually take you in circles and you'll, okay, quick question. Has anyone used Google Map and gone the wrong way? It suggested a wrong way, a dead end way, or have you ever tried going in circles? It's a good question to ask. Everybody would have. Exactly. So that answers your question, right? So again, this is artificial intelligence kind of system. We try to make it like 100% correct, accurate all the time. But again, there are gaps all the time. Even Google Maps, I'm just taking Google Maps as an example. That has also gone wrong, right? It does make huge blunder. But again, over the years of refinement, fine tuning, it is actually in a better state. But still, it can go wrong, if you understand my point.
Yeah, heuristics is not mandatory for routing, right?
For informed search, yes. So there are two classes. If you wanted to go for informed searches, then heuristics mandatory. If you want to go away from heuristics, do blind search like DFS, BFS, Digitra and all is actually weighted average. It does not have heuristics. To answer your question, heuristics is not mandatory if based on the choice of algorithm. Okay.
Can we go to the graph?
I'm trying.
It's-
Can we?
it's-
Okay, last question. Yeah.
I'm just understanding. So if it is greedy best first search,
BFS?
it will go to A, B, E, Z,
Right.
that route. And if
Right.
it's A star, it will be A, C, F, E, Z.
AC 12 plus 8 is 27. Yeah. ACF is that correct?
Okay.
That's correct.
Good. And it's the session is more interactive, I see. The session is more interactive.
Okay. Okay, that's good. Like more questions better, but I just cautious of time. I'm just speeding up because we need to also do the hands-on. So let me go back to the screen where we are actually talking about A-star algorithm. We'll start with heuristic computation. Everyone is clear, right? We'll go to the A-star algorithm first. I have also implemented GBFS, but let's, in sake of time, I'll just quickly fast forward. So A-star algorithm, what it does is actual distance. If the actual distance is G and heuristic is H, it actually tries to sum up both this and then try to figure out, okay, which is the lowest and then tries to take that route. Clear with the use case, right? So what I did first is I created a heuristic matrix. I wanted a matrix. Again, I'm using Haversine formula. Again, this is a representation of our part and I calculated the heuristics. Again, this matrix, it will tell you, okay, what is the great circle distance between two cities. Again, every city is mapped to every other cities. Diagonal every entries will be 0. Why? Same city we are checking. So distance will be 0. That's good. Okay, someone is paying attention. Representation part. Representation, I think I already covered. We just wanted to create a map into some structure. I'm using a class structure with array. Again, there is no hard and fast rule. If you wanted to implement with your own data structure, complex data, all these things are possible. Now, next step, we are trying to implement the algorithm. So let me try running also. That will give you an idea. Let it run. Okay, it is running. So A-star algorithm, what it does is, I just created two paths. What is my traversal path and what is my traversal cost? Traversal path will tell you, okay, which all cities I'm going to traverse through. Just a string array. Simple enough. Traversal cost will just sum up. If I try to traverse to this route, what is the kilometer, actual kilometer, it will start summing up. Just incremental counter. Okay. What this algorithm is doing is, it will try, okay, I wanted to go from city A to city B. So it takes the current city and the target city. What is my starting point and destination? It will try to convert it from the data represented. It tries to get the node, and then it appends it to the traversal path. I'm starting from Panaji or some city. I need to start listing in the traversal path so that I know I'm starting from this city. So I'm just putting it here, appending it here. And then when I'm checking, okay, is this city my target city or not? If I wanted to go from Panaji to Panaji, I don't need to end my algorithm, right? Program. So I'm just, every node I visit, I'm checking, okay, is my node the target city? What I'm checking is his goal node. It's just checking the names, basically. Clear so far what it is doing? Now, and once it is not the goal node, it will try to expand the next city node. Okay, so it will try to find the next connected city. What this next connected city is doing is, it is constantly iterating through all the connected cities. For example, this example, Panaji has 2 connected cities. Panaji has Bangalore and Raichur. So it will try to iterate through all the connected cities and try to see 365 plus what? Heuristics. Heuristics, which one is lesser? That is what it is doing. Again, one more check I'm doing. I'm not already visited that city. If I've already visited that city, I need to break. I need not consider that for like traversal because it will go in endless loop circles. In heuristics correct, it will not go, but I just added this check. There can be multiple wrong things also coming up. So what it is doing is connected city dot distance plus the heuristic distance. Okay. So before that, I checking and then trying to print the actual city chosen, which traversal path I need to take. Before that, I am checking, okay, if there are 3 non-visited city, you'll try to take the 0th element from that. Okay. I'm taking one reference. Okay, if there are 2 nodes, say 1, 2, 3, I'm taking 1 as the first node. I'm choosing that one, and then it's compared with 2. If 2's actual distance and heuristic is less than the first one, it will take the second one as the city chosen. Then again, it compares 2 and 3. Okay, that is what it is doing here. Clear on the program, what it is doing? Okay, so there are some functions here. So what it is doing is, so all these are actually, getting the heuristic distance. So heuristic distance between cities is actually received. We are converting from the metrics, which row I need to go, which city are we talking about. And from that city, I need to get the column element. That element will give you the value. That is heuristic value. Again, both are actually summed here. So this line, connected city plus distance, it is getting summed and then compared with the city chosen. Let me run this program. So in this example, what we did is, initial city I am choosing as Panaji. I wanted to go from Panaji to Chennai. And the target city destination is Chennai. So let me run this program. So what it does is, I think it ran. So it is saying, okay, you need to take it from Panaji to Raichur, Raichur to Kurnool, and Nellore, and then finally Chennai. So this is a path. It's saying in the total cost involved while going through this one is 1057. That is the total distance, basically. It is summing up all the distances. Clear the program? I don't want to try different cities. I'll go back to the problem statement. City we wanted to go from where? Any cities you can choose. Kozhikode, okay. Kozhikode.
Mangalore to Nellore.
I'll take first one. We'll try both. Kozhikode and Tirupati, right? Okay. Let's try Kozhikode and Tirupati. One second. There it is. So what it is saying is, if you wanted to go from Kozhikode to Tirupati, you need to take a Bangalore route, and then from Bangalore to Chennai route and Tirupati. Let's go back to the possibility. From Kozhikode, Bangalore, Chennai, and Tirupati, this route. Clear? Okay. Anyone else wants? Someone was asking for a different city. Anyone wants to try? Please check the chats. Okay. Anyone want to try a different city? Where do you want to go?
Maybe I got a question. So since we are using the another unit, the heuristics as a distance, we are just summing up. But if you are using minute or the timing, so then unit need to be calculated somewhere in a weightage so that it can be added with the distance.
Right. So heuristic does not have a measure, like a unit. It is just a measure. So if you're considering kilometers as the distance, like comparison, heuristic becomes a kilometer unit because you need to sum it up. If you are thinking of time concept, for example, time is actually very important. If you think, okay, how much time is what is the concept? So it is telling, okay, from one city to here, you have historical data, it will take 30 minutes. So that 30 minutes becomes your heuristics. You get my point, right? So heuristics does not have a unit in a nutshell. It takes any format what you are comparing to. If you are comparing the distance, it takes a unit of kilometer.
Actually, heuristic is just a weightage. It's just a point,
a measure,
point that you get. For each of these nodes, you have points associated. If you go to this node, you'll have a point. This one will have another point. So that point is calculated. The algorithm is different. The way you calculate the point can change.
I have a use case actually. I don't want to skip. I want to skip all the tolls. I don't want to pay for tolls. Actually, if you think of like, there are many tolls in, at least in Kerala, the route of highway if I take, I want to skip my toll. So it suggests me to roads without tolls. I'm just taking an example. So in that case, heuristic becomes like which route without any tolls. Any heuristics with tolls, it will like increase the heuristic count for that route, such that it does not take that route. You get my point? So heuristic does not mean like it is kilometer, it is time. It can be any number, a measurable unit basically. You are saying. Right, because my objective is I don't mind the extra kilometers, but I don't want to give the toll. I'm just giving an example. Someone might, for some people, distance might not be a concern. Time might be a concern. I just wanted to go there, even if I'm traveling 5 kilometers extra, I need to reach 5-10 minutes early. So the objective will be time-based. So it depends. So what kind of application? Blinkit and all, it is time-based. I need, whatever is the distance, I need it in 10 minutes. That is the agenda. So it depends on. Right. Again, I don't want to bring it here. You can do that. Again, your data representation needs to change. It needs to account into, okay, is it one-way route? Is it two-way route? It will be more complex and more. Again, we don't want to discuss there, but it is possible to do that. Okay, I was in a discussion. Anyone want to search a different city? Who wants to go where? Also. That's fine. So I'll show one more algorithm that is called GBFS. I'll go back to previous state. Just wanted to show the example. So I'll go back to Chennai, Panaji and Chennai, Goa and Chennai example. So for it is showing me Panaji, Raichur, Kurnool, Nellore and Chennai, this route to traverse. And it's also telling me the kilometer, like 1057 kilometers, if you take this route. Okay. Now, if there is another algorithm, I think I was telling you two different algorithms, right? One is A-star algorithm, one is GBFS algorithm. GBFS algorithm, if you try to implement with this exact same data, it will try to find you a different route. Okay. I think I have already ran it. I didn't need to connect and run, but I'll just show you just quick example. So if I wanted to go, this is GBFS algorithm in place. What is the difference between GBFS and A-star? Actual distance. Exactly, you're right. So that is what is happening here. So if you see here, find next connected city, it is only using the heuristic distance between those cities are lesser or not, and that it's trying to make a decision. In the previous example, it was actually also summing the actual distance, connected city dot distance. Here, I think that is the only subtle difference, but implement outcome wise, there is a difference. So here it actually showed me different cities. It needs to take the Panaji route from Panaji to Raichur, then to Tirupati, then to Chennai. The kilometer range is slightly higher. But again, objective differs. If you are okay with the extra distance, but the time is of essence, then you can actually tweak the algorithm. Again, Google Map is not just A-star, it has multiple more. So I don't know whether this route also has tolls, right? But yeah, right. Based on objective, actually the choice of algorithms, everything matters a lot. But if you think of like simple distance, A-star is the most commonly used. It's a very optimal and complete kind of algorithm. We can use that. Okay, I think that's it I had for the demo. So I'll open for questions. I took more time than anticipated. All right, so any questions like so far? How was the session?
More interactive.
Good to know. It's bad, good.
So you brought up in the beginning whether we build our own or use the existing surveys. If you're going with Google Maps or OpenStreetMaps, so we just call a function for finding the shortest one, kind of. That's how it's available.
So there are SDKs, APIs, SDKs that you can use. But again, that comes with cost. If you wanted to, for example, I wanted to use a simple bakery example. I am starting a new bakery. They wanted to do delivery from that bakery nearby, say 10-kilometer radius. That is objective. You don't need to buy Google Map. You know the map around in and around of the area. If you have already the knowledge, you can make a very simple use case. Get my point, right? That depends on that what you wanted to build. If you wanted to buy a entire thing which is mapping across all India, then it will take a huge time. But again, there is if it is a consolation, Ola built it actually for India. And it's actually being used in all of their apps, Ola scooters. If you use, it is actually using Ola Maps. Again, what kind of use case business or what you are trying to achieve?
So it's like sometimes we are going on a way and Google Map will show there is a traffic road is blocked. Right. Maybe since they're giving Google Maps is a free for everyone, so they will, based on that, they will find whether people are passing through or it's stuck. So that data may be missing
in Ola Maps,
with the Ola Maps only. So, but in our use case, if there is if it's need to be considered, then we have to go with Google Maps. If that is not a concern for us, then we can go with Ola Maps, right?
In all this comes to your business decision. So if your business decision is, I don't need to be like 100% of accurate, the route which I take, I am okay to flexible with 80%. And if you try with Ola Maps, it is giving that accuracy of 80%. It is trying to find the optimal path. Then you can go with Ola Maps, which is actually comparatively free and cheaper. I think like as I said, because of this disruption in the industry, that monopoly is actually going away. Not going away, it has started. So that's why to counter that only, Google also like retaliated, reducing the cost. They're giving crazy discounts. If you are an ONDC developer, you are getting 90% off on the previous rates. Again, just giving an example, but it's actually good. I don't like monopoly all the time. It's always have to in. Duopoly is also not good, but I'm saying still it's better to have choices, right? Okay, language modeling is a different topic altogether. Yeah, but if you're interested, we can do that in another session. You need to speak with the recruiter. Right. Again, the tech landscape is changing. Language modeling, there are different battles happening. Again, this is something on the AI side that is more on the language model, LLM side.
Similar to this.
Okay, that is totally different. LLMs are totally different.
No, I told in business approach.
Right.
When DeepSeek came, they also.
Right. Everyone wants to grab their own market share, and they will do that for like crazy things. They will do. Again, giving discounts, free tires, all these things. Again, to gain customers. Even I'm thinking an example like referral bonuses. Why do companies pay you some money to get you someone? Because they wanted to get the market share. Something that investors also will try to do. Once you get the market share, it will change. Like paradigms, everything will change. But yeah, that is a totally different topic. I don't want to go to language models, LLMs in this one. Any questions here? Yeah. Okay. Right, then I think we'll stop for the day. If you have any more interesting topics you wanted to share, please reach out. If you want any more interesting discussions, I'm happy to share. I'll take a pause here and then stop the recording. All right. Thanks for joining then.
Thank you.